Hello, fellow trufflers. This video is mainly filmed during the mycology session of the Barcelona Truffle Tour in 2023. In this video, we will get down in the weeds, or should I say in the roots, about identifying and testing seedlings for colonization. This video is two parts, the first showing how to prep and count colonization of the truffle on roots, and the second shows some basics of PCR testing for the presence of truffle DNA. Hope you enjoy and learn something. Thanks.
So the first step is to remove the plant from the container and then clean the plant in a cool water bath. So in our case we have a lot of roots. So what we do is use only a quarter part of the root.
The first step is to remove the seedling from the container and place it in a bath with cold water to remove most of the potting media. Monica is pointing out that normally in Spain a 2-year plant would be half this size with fewer roots, so they may use all or half of the roots based on some formula. In this case, there are a lot of roots, so we only use a quarter of the roots. According to the Fisher-Colinas method, one must analyze 1% of a batch of trees plus 2. For example, if there was a batch of 1,000 trees, 12 would need to be analyzed.
Plant of a batch of plants. So if I have a batch of 1,000 plants, I need to analyze 12 plants. So, okay, now I need to cut all the roots in 1 or 2 centimeters section. Yes.
You completely destroy the plant, and the idea is to be random. Because it's easy to.
The trees for testing should be chosen at random. The roots should be cut from the top to the bottom. If a tree is well colonized, the mycorrhizae should be everywhere. And finally, the roots need to be cut to 1 to 2 centimeter lengths.
Pass the exam with this. Everything is perfect.
A grid of squares with different colors and a sequence of numbers for each color is used in the counting process. Before counting the colonized roots, a color square is chosen. In this example, the green square has been chosen. The roots are then poured onto the grid and covered with cool water. Large chunks of the substrate and roots are then removed. These would interfere with counting because they could block a mycorrhizae root.
Microscope.
No te mojes, ¿eh?
Pero no.
Espera.
Do you have a template of the color thing as a printout?
Sorry?
The template for this color thing as a printout.
Yeah, we have to template.
Yeah, you have a template.
Yeah.
The grid plate is then moved over to the microscope for counting. They use an app on the phone to help with counting. In this case, the black color signifies no mycorrhizae, the green is positive for melanosporum, and the red is contaminated. They'll go through each green square in sequence, starting with number 1, and count what's in each square.
No, this is a normal counter for sale.
I use cell counters. It's the best. But you can use the old method. It's like when you go to when you went to the cinema 20 years ago, like this, clack, 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 clack. But I discovered this counter, and it's better because sometimes you have counters that have different sounds. So you can do it just counting and click, lock, and you know that you're not wrong.
Okay, so we go to the square number 1, the green one, number 1.
Yeah.
So we have to count at least 250 root tips. So it's important to know the amount of root tips, the total amount of the root tips, because as you remember, I explained you that you need to have at least 900 root tips to be okay.
Monica's discussing the number of root
So
tips
depending on
needed.
how many
The
squares are
seedling
you using
must
when you use
contain
the
at least
formulas,
900 root tips on the
sometimes says
entire root
we
system
used
to
to have, I
be
don't know, 10,000
viable for planting.
root tips.
Okay, so this is the square number 1.
Yeah.
So
In this last
see
section
that
on
this one is a
identifying
mycorrhiza.
colonization, it
This one
shows
also is a
working
mycorrhiza.
under a
This one-
microscope and identifying mycorrhizing and potential contaminants.
that one no is a tip. Also this one is a tip. It's a broken tip.
Yeah.
So okay, I have 1, 2, 3, 4 mycorrhiza. So I put 4. And this one is not. And this is broken, so I don't put it. So
And you have to decide if you want to count the lines or not, or which lines you count, because you have 4 lines. And you have to decide first if I want to count this and this, or this and this. If you have 100 mycorrhiza here and you haven't chosen these lines on the square, you cannot count it. This is a terrible method.
Yeah, but that's why the squares are basically all over the field, so you basically it compensates right throughout.
Okay,
Yeah.
yeah. And now you have to move slow until you find number
Until
2.
the number 2.
And sometimes everything falls down because you are trying to count, especially me. I cannot count properly. You used to count.
With the camera it's not very clear, but
But you
I
can look
see.
at
the microscope I think it's better.
Yeah.
But okay, in this case,
This is
this
one,
is a
yeah.
mycorrhiza.
Yeah, that's also.
This is also a thing. This is not.
You can check it here. Maybe it's better. If you have to count, you have to decide if you count it or not. Now you're the professional. Check it.